Hey, what's up, guys? In this video, I'm going to walk through this problem from Pramp, flatten a dictionary. So we are given a dictionary. We need to find a function flatten dictionary that returns a flattened version of it. So let's look at that example. The given dictionary looks like so. The key number 1 has a value of 1. Key 2 has a value of another dictionary. And within that child dictionary, we have the key of A is A as a value, B as a B3 as a value, and C has another child dictionary, and D has a value of 3, and E has another child dictionary, and the last one has a key of an empty string and a value of 1. So what we need to return is a flattened version of it, where key 1 is 1, basically is this part, and key 2 dot A, and A is a key in the child dictionary of key 2. So that's why we have a key 2 dot A has a value of 2, and that comes from here. And key 2 dot B has a value of 3, and key 2 dot C, and C has a child dictionary, and so key 2 dot C dot D has a value of 3, and then key 2 dot C dot E dot in the most inner dictionary has a key of empty string and a value of 1. So that's why we have a key dot 2 dot key 2 dot C dot E dot actually empty string, but this is empty string, that's why we don't need the last dot, and then the value of 1. So we can use a DFS plus recursion to generate the flattened version of it. So let's dive into and feel free to pause the video right here and then try yourself. And now I'm gonna dive into my solution. So, and this is a recursion. We will solve this problem using recursion and DFS. So same as other recursion method. And first, we need to have a terminal condition. So the terminal condition will be if the given value is not a dictionary, so that means this actually is a string, right? In this case, it's a string, and we append the parent key, the given key actually, and then append the value to it. You see, this is the flattened dictionary. I call it O. O stands for output, and the key being the parent key, and the value being the given value. And then we don't have to do the rest, so we return it. And else, meaning that if the given value, so that value from input to the function, is a dictionary, that means we have a child dictionary. Okay, so for each of the child key in the given value dot keys, because this right now the given value actually is a dictionary. So for each of the child keys, and if that key is an empty string, so basically it's this case. Okay, if that key is an empty string, and then we recursively call back this function by inputting the parent key and then the given value, where the given value right now is a child dictionary, and look at the child key, and then put it back to the function, and then we call it recursively. And else, meaning that if the child key is not an empty string, means like for example D, E, and A and B and C, all these are child keys, and they are not a empty string. And now we want to check the given parent key if that's a string or not. And if that's not a string, we can have a dot and concatenate the parent key with the child key, and then the value is the same, right? So we look at the parent dictionary, add the child key, and then put it back to the recursive function. Else, meaning that if the parent key is an empty string, that means that we don't need to concatenate, right? So the parent key now is an empty string. So we put it back to the recursor where the child key is the input argument and also the same value, right? This is a child dictionary. The value at the child dictionary. And to trigger the function to run, and we just have the input dictionary and look at each one of the keys in the input dictionary. Let's run that, and it passes all the 6 cases. Time complexity is going to be big over because we visited every key in the dictionary only once, and that's why it's a linear time complexity. And by the way, sorry about that. And n is the number of keys in the input dictionary, so big O. Space complexity is a little big O of n if we are counting the output dictionary. At the same time, we also have some storage. Comes from the recursive call, which comes from here. This is my solution. I hope this is helpful. If it is, please like and subscribe. Thank you so much for watching. I will see you in the next video. Thank you.